So RFI MR14 for the Make Ready building, we produced this RFI, and we're gonna be producing these types of RFIs. This should be like second nature to anybody in the room. It's an RFI. Why did we write it? Read the question. Tell me why we wrote it.
Because it looks like approximate building corners. Usually it is a building corner, not approximate. So it looks like something got shifted or it was thrown off most likely.
Right. And what do we need exact numbers of horizontal control for?
Origin points and surveying off of everyone works off the same system.
Yeah. Surveyors who gets us started and places the building, and if they don't have exact numbers, we don't know where that building goes on site. Even if it's a dead empty site, somebody designed it to go in a specific place, and rarely are we working on, completely empty sites. So that is exactly what we wrote the question for. Is all they gave, if you look on the original horizontal control civil drawing, they gave an approximate building corner of the existing building that's here. And it's a split face CMU block. So how precise is that? Right? I mean, you got rough edge, and they gave coordinates. So we said we need the coordinates of the actual grid intersections, and we just pasted our own from the understanding of the plans and overlaying and QCing it in CAD. We can say, hey, here's where we think you said you wanted it. Please confirm these numbers. And so we only really need a couple of these. A grid intersection coordinate at like opposite corners of our site would do us well, but we put as many of them as we could, or at least quite a few, like the kind of four corners of each building. So you got the Make Ready building, and they confirmed. They said, yep, those are the numbers. So now we know, we pass this along to the surveyor. This would be a question a good surveyor would ask this anyway. He couldn't go out there and even start without it. So we asked it ahead of time, because now that we use a total station, it's important to us. And it's kind of good that we're starting to do that, because the only way, so the plumber out there kind of noticed a bust and said, hey, I think there's a problem with the grid, the survey laid out. And he said, can you check it? And I checked it, and sure enough, he had laid out the entire building 4 inches east and 4 inches south. So his question on our go-to meeting, once we showed him the problem, was, should we just shift the whole building? Now, in a site where it's a building separate from anything else, maybe 4-inch shift is not too big a deal. But in this case, where you're meeting it right up to the footings of another adjacent building, I mean, we only have a seismic separation. We pointed out to him that the seismic separation is specific. No go. Come out and fix it. Because the problem was, he had already laid this out weeks before, and they started stringing lines from it and laying out electrical. So I would have thought the electrical would have maybe found it sooner, because we went out there and laid out for them the corners of this room via the total station. So if you can see this conduits here, I'll show you.
Oh, sweet. You got 2 people standing there.
Yeah, there's all kinds of guys moving around on site. But you can see all these conduits, right? So we gave them the 4 corners, stud corners of this room for them to hit. If they'd have used those, I guess unfortunately somebody had already come along, the plumber had dug a trench and taken out 2 of them. They had 4 nails in the corners. Well, then they just started using the grid lines. So a lot of this conduit that they went in first because they're deepest is missing. Well, how much? Now the surveyor's paying for these guys to come back and fix it. Some of it's encased. A lot of it isn't, but he's now paying for this change order because these guys were done and we should have been moving on. Now we're losing time. So how much does he move? Now they're all leery of using the grid lines, even though we made them reset them. We checked them. They're good now. We can see that quickly. So what we're going to do is we're going to use CAD files, Revit models, Navisworks NWCs, and this laser scan, and we're going to lay them all together precisely with the civil coordinate system in Navis, so that you guys could see how you can section it down and use it just like a Navis Clash model, but to say, hey, see these conduits? See how they're missing the wall? Or they should be outside of the wall and they're actually in it, and give them dimensions and everything else. So last bit of background to all of this, how do we get this done? Along with you guys having access to full Navisworks Manage, as a glue user and a project admin, you have the option for having this Autodesk point layout software. If you have either A, Revit, or B, AutoCAD, and again, that's another reason we're trying to get this remote machine set up to where you guys could, have this. We would typically set this up for you, but what it is we can export any view, floor plan view, whatever, out of Revit on a coordinate system that matches these exact coordinate points, right? So, for instance, this AutoCAD file, if I'm going to check that, let's see if this matches up. I'm going to be looking at the corner of the make-ready building, grid line G.4 and 7 should read those numbers in AutoCAD. So I'm going to come down here, G.4 and 7. I'm going to do an ID on this intersection. And I don't know if you can see those numbers down there, but it's 5237.80, okay, and 4564.47. Okay, so we have this CAD file. That's how our total station works anyway. This is kind of the background to our total station. That's on the coordinate system. We also have the ability to make multiple coordinate systems in our Revit models. So normally, you guys have been through, if you've been through any of the BIM trainings, Serenavos would know, we have to set a coordination origin point for everybody to align their models to, right? Otherwise, they come in at different places and nobody's model aligns in the building. We can make another one of those on the civil coordinate system, because normally we don't want to work in a coordinate system that's 4,000, 5,000, right? We want to pick a grid intersection and say that right there is 0, 0. Make it real simple for everybody. That's what we do for BIM coordination, but for site control, survey control, you have to stay on the surveyor's and the civil engineer's coordinate system. So this CAD file is ready to go. Do you think we can get this laser scan that way? Any guesses?
To coordinate with the coordinate system?
Yeah. Do you think so? You've all, most of you seen our laser scanner, right? We come out, it's there's the shadow of it. Sits on tripod, every scans somewhere between 30 and 50 million points, and then it puts them all together into a 3D point cloud like you're seeing here. Can we put this onto a coordinate system?
Yes.
Yeah. How do you think we do it?
Oh.
That's good. Yeah, you just order it to be there.
Well, no, but I mean, I'm
Yeah.
sure there's a setting where you say this is where this, like, you click on a point and say this point should be in this location.
Pretty close, yes. So you notice that right there? That is a target that's designed to be detected by the software of the Faro scanner. So that little, basically looks like almost a nuclear waste symbol, but you notice we have 1, 2 on that wall, 3 of them. Okay, those are needed for either A, precise registration of point clouds, and B, you notice our total station, I guess it wasn't set up on the hill yet, but there's the plumber's total station. So our total station, when set up and synced up to survey control, can then shoot the precise crosshair of that and give us exact coordinate to that, and our scanner recognizes that, and we say that point is this coordinate. And you have to do that with 3 of them so that it has its geospatial relationship, right? And so we are doing that now. This is something, another reason we wanted to purchase that equipment was for the many reasons. One of them is this. Now we don't even have to guess anymore. We can go out and scan, shoot targets, bring it in, and it's on. We could tell somebody when their wall is 1/8 off or 1 inch off or 1 foot off, whatever it be.
How many projects have you guys shot where you found there's a discrepancy between the building corners or something along those lines before they even start digging or in the digging?
This is probably the first one we've really done a lot of checking of the surveyor. BCT, Mount Sac BCT, we worked with the surveyor a lot Jeff Blackall's really good. I never found any errors in any of his stuff that he gave us. But it was kind of already going at that point. We're doing that. We're going to do that pretty much on every job now, going forward. We've checked EHS, come out there with the total station, sync up, and then start shooting things to confirm. Are we anywhere close? I mean, lots of CMU is easy, right? Face of CMU is a grid line almost every time. So you scan that on survey control and bring it in, and you know right off the bat. And Orlando could show you after. We have that scan we did a few weeks ago of all the CMU, and it's brought in via survey control. So, yeah.
Just a quick question. It might be something they're wondering. The total station itself, how do you determine where the total station itself is in the coordinates? How do you gather that information?
You bring it out on site, set it up somewhere like this. In this case, ours, we set up on top of this mounded dirt and sync up to the control that's been established out there by the civil engineer and the surveyor from the beginning. And so that's kind of written into our scopes now for survey, that they're going to give us some more control points throughout because we use our own total station. They have to make those available to us. And sometimes they give these guys grid lines, and that's what a plumber, their total station's simpler. It just wants 2 points. And you say, I'm giving you this one and I'm giving you this one, and you shoot them and you say that's grid line intersection this and this. And if the measurements are right, it's happy, right? If it matches the CAD file, they're good. There's no way of knowing, hey, is that really right on the right coordinate system? That's a full survey total station, which is what ours is. So you come out here, you set it up, and you shoot. There's mag nails in the street that we've had the coordinates of. There's scribes on the top of this wall behind the fence. A number of things we can check. You got to have at least 3. The math has to work between them, the trig, I guess. And once you're within tolerance, the total station knows its position then. Then anything else you shoot has that same coordinate system. And that's what, go ahead.
I'm just curious, what coordinate system does everyone use universally? Like, is this the GPS or like northing 4,525 point something? Like what?
So that would be what you'd call a local coordinate system, because the state of California is on state plane coordinates, which is they're mapped out in zones, and then all those coordinates will usually be around 6 million, 1.8 to 2 million in the area we're in. You go to the north part of the state, the numbers will be different, but they're working in that size coordinate system, and that's the state plane coordinate system, and that's what California uses. So surveyors shoot typically in state plane coordinates. When they come into a site like this, where they're not necessarily trying to locate a new building on a new piece of property, they're trying to locate it in a local coordinate system and get it right aligned to the existing building. They'll set up sometimes just an existing a local coordinate system like this, where the numbers are smaller, simpler, but they can do it either way. But most of our other projects, though, Etiwanda, Mount Sac, those are all state plane. We're working in 1 million or closer to 2 million, 6 million coordinate systems. So let's go ahead and take a look at how we can put this together in Navis, right? So you should have in this file set, and you guys have a copy of the scan file. So if you're in Navis, first thing we want to append is the NWC that I've exported. So let's go up to the home append. So I know some of you haven't used Navis much because you haven't had the previous trainings, but you're going to go to append. You're going to go to that desktop folder you have. Desktop, so I don't mess up the original. TCC training, laser scan. And pick out the one that says BIM 360 layout export architectural walls.nwc. Does everybody see that there? This guy? Okay, so just append that one only for now.
Ignore all conflict or whatever.
Conflict? Oh, like missing?
Yeah.
Yeah, ignore all. And you should see this. Okay, tell me when everybody's caught up.
What project is this? Cerritos?
Parkview ER.
Oh, the hospital.
Yep,
It's Eric's project.
that's right. So if you remember from previous classes, one of the first things you kind of want to do, Revit likes to, or excuse me, Navisworks likes to be in a rendering mode initially. Just go up to the viewpoint tab right here, mode, and change it to shaded. Now, what this is this is a view from the Revit model, exported. You can tell, like you just learned, with a section box, right? You can section a model down. This was cut with a section box and then exported to glue, so we can just download that NWC. And this will help us. We don't need to see everything above this. We're only got underground, as you can see out there. That's all that's been started. So we're first I want you to understand the principles behind this. So I want you to take and select this model in your selection tree, right click on it, and go to units and transform. And tell me what units that file is in. Feet. Well, just you want to know what Navisworks detected the units to be. Okay, so this is important, and we're not going to get into the conversions of units, but for example, in AutoCAD, a civil engineer draws very large stuff, right? Sometimes entire, city maps. So they use a unit where they say 1. When I type in 1 inside of AutoCAD, I want that to be a foot. I don't want that to be an inch, because now I'm going to have to type in bigger units, right? So they use one unit equals a foot. What do architects use?
Quarters, eighths, sixteenths.
Well, they use inches. So there's a foot unit. That's what civil engineers use. Architects use inches. When you type 1, it's going to go an inch and treat that as an inch, right? If you needed to go a foot, you'd have to type 12 inches. So it's important that when you're working, normally everything's in inches, right? When we're in the building, all our clash models, all inches, pretty much. What does our FaroFocus laser scanner record and capture scans in? It's a superior unit of measure.
Oh, meters.
There you go. An easier one to convert, and one that the entire world, I wish, used. So it records in meters. So always that data is in meters, right? So just important to note, it's reading this model in feet. Now, this is the first one we brought in. Navisworks will sometimes try to adjust ones you bring in to make it match what it thinks. Oh, these are already in feet. I'm going to switch this one to feet too. And it kind of screws it up. But we can switch it back. So I just wanted you to see that here. Sometimes that happens when you bring in two models and you notice one is like way smaller than the other. It detected one is feet and one is inches. And then one's going to be 1/12 the size of the other. So the next one I want you to append is the CAD file. This is that background we just looked at in CAD that is also on the coordinate system. Before you go ahead and do that, append that in. I wanted you to notice too the origin of this previous model. If you notice, those numbers are very similar to what we were already looking at. 4,500, 5,000. It's on our civil coordinate system because I exported it that way out of Revit, just so you know. So now I'm going to append in that CAD file, the Leica BKG for the ER. DWG is the one you want to add. That's the authoring file. That's the original. Now, anybody see it?
I do. It's a little pink dot in the middle of nowhere.
Okay. You can often hit the top view of your view cube, and you notice way down here in the corner, it'll almost always zoom out to show you everything if you hit the view cube, top or front. So here's this tiny little CAD file down here. Okay. So what's wrong with that? This is, zoom into it. This is our same floor plan. What's happening here?
It's the wrong scale and wrong origin.
It is the wrong scale, but we already checked right here. It's on the survey coordinates, and this is the same file. So what do you think we need to do? Of what I just taught you, what do you think we need to do with that new one?
Units and transform.
Okay, so yeah, right click on that Leica BKG, units and transform. What did it detect it as? And what is it actually? It's a civil. I set it up as a civil background. So what would I have made it, the units? Inches or feet? Feet. So switch it to feet and tell me what happens. No, it's deceiving. So check this out. Watch this. Oh wait, is it below? Is it so Navis is always in a perspective mode. So it's kind of showing you like your eye sees. It's actually lined up. If you hit top, notice it's directly below.
Right.
Okay, so what is it about the CAD file? Is the CAD file, zoom into it down there. Is it 2D or 3D?
2.
Yep. This is just a 100% flat line work. So it has the coordinate system. Does it have true elevation? Okay. I'll give you a hint. Like every project, surveyors also work in true elevation. How do they know if the finished floor of the building is getting put in right? Right. This one is very critical. This hospital, where you exit or you go into the existing hospital, is a foot higher. This slab has to be a foot lower, and then this make-ready building is even a different height than that. So surveyors work in true elevation. So this model, if I zoom in here and I use my coordinate readout, which you guys might not have, you'll notice my coordinates right here. I'm around right where my eye is now, and Navis is at 775 feet. Finished floor is found on our documents, right? Civil engineer or civil plans show us finished floor elevation. So I'm going to give you that. Finished floor elevation of this model is 753.6. So that's what? 753 feet and, sorry, 0.5. 763.5. So that's 763 feet, 6 inches. So back to right click on the Leica, units and transform. Because it's just a 2D CAD file, we have to put that in the Z coordinate. And I wish they labeled these. It's kind of lame that Navisworks. So this is X. The first box is X, then Y, then Z. So 763 feet, 6 inches. And you do have to leave the FT in there with Navisworks. I'm sorry, you're right. 753 feet. No, wait. I'm going to have to look this up. Eric, help me out. Where are we at here? I got it right here. I'm just going to go straight to it. Civil grading. Let's not screw this up.
Jared, what was the question?
Finished floor elevation of the... There we go. Okay. So that's the number we want. 763.5 decimal feet is 6 inches. Okay. Also important to understand. Now what happens after you change that? Yeah, if you want to see it again, make sure when he puts it in, Blair, that it's 763 FT space 6IN. Okay. I wish you could type 763.5 and have it be smart like Revit. Revit will automatically convert. Navisworks does not. So now, if you did it right, you should have a CAD file, as you can see, right at the floor, the slab, right?
I still had 1 or 2 elements that didn't come up for whatever reason.
Really, there's things down in the way down there? You only have 2 things in the whole Navis. What is it? Help him out.
Looks like grid line A and 1 and 2.
Oh no, that is that. Sorry, do you?
No, it's just the Navisworks.
Yeah, so you have this option turned on,
Yeah.
and so when you have Show Grid turned on your View tab, that can be deceiving because you can tell at what level, like at a fixed level, and if it's at Civil Base, now check that out. That's what you're seeing. That's Civil 0. So that's 763.5 feet down where the CAD file used to be. You can switch it right here and just change it to ER Department Finished Floor. So you want Show Grid, the mode should be fixed, and then you tell it where it's fixed, ER Finished Floor. And it should bring it all up like that. Sweet. So we now have a CAD file. We now have the 3D architectural, and if you notice, structural concrete is exported out with it. I believe even steel, if I'm not mistaken, is in there. Yes, it is. Okay. So for a minute, just so we can see this all better, we're going to hide this first NWC. So click that, right click on it, and hide it. Now that we know that this CAD file and the 3D are lined up, let's just make this whole CAD file blue. How are we going to do it?
Override item.
Select the item. Yep, you can go up here to Item Tools, Color, under Appearance, and just go all blue. So now it should be looking like that. Okay, and here's where it starts to get cool. I'm going to turn these grids back off, by the way, because we already have grids showing in the CAD file, so that's good enough for me for now. We can always turn these back on. By the way, these intelligent grids that stay zoomed in and stay at the edge of your screen, which is a nice feature, those come from the Revit model, just so you know. That's something they added support for a few years back, which is huge. Okay, it's time to bring in the laser scan, and we already put this laser scan together. It was 14 or something scans. I registered them all. I gave coordinates to those targets, and I also unified it. So what you guys are using, you should have in your folder, is this file right here called, I'm in the wrong one. Let me go to the desktop copy where I put it. ER Underground 2017-1212 RCS. You notice it's a 5.8 gig or something, 5.4 gig scan.
RCS file?
Yes, so what I did is I took all 14 scans, and I can export it, and I could tell it for one, hey, if that thing sees a long distance, so I just kind of cropped around the property, and then you could clean up stuff too. You could clean up those people walking around getting in the scan. And then exporting to a unified scan means it takes all the data, those millions and millions of points, and it looks on every surface and says, oh, you want me to decimate everything out that's closer than 2 millimeters. So it leaves only a dot every 2 millimeters, which is like a 1/16 of an inch. So it's still very dense, but the full project is like 9 gigs. So you could go, this is a 2 millimeter decimation. You could go to 5. It would still be plenty of data, and it would cut that number way down for portability. But this should be good. RCS files are pretty fast processing in Navis anyway. So we're going to come back over here. We're going to go to Home, Append, and if you just switch to the All files at the bottom here, Navisworks reads all of these. So you should be able to attach that RCS, hit Open, and you should get that result right there. So now check this out where you zoom in. Now it's getting to be some real data you guys can use. I mean, this is the actual trenches, pipes they were welding that day, and where it relates to your exact project, like future and existing overlaid. So you're looking at like, now show me that data room. Somebody find right away a problem with this data room.
Conduits are out of the wall.
And actually, most of them are supposed to be out of the wall.
Oh, the panels.
So find me some that are, right? I mean, like this one's directly in the wall, as you can see. And those are supposed to be outside of the wall, inside the room, to go to surface-mounted equipment. That's possibly, but you're going to section it down. So one other thing you can do to start helping you out is you can expand this Leica background file right here. Hit the plus symbol next to it. Scroll down till you see A wall. Select that layer only. Go up to Item Tools and make it like magenta or red, something that stands out to you. Okay. Now that line work is your stud lines. So can you see how it's red? And now you can start to see where things really don't line up.
Where's the color on Item Tool again? Oh, I have to put it in one.
So does anybody see a problem with Couts Chase right here? See, let's go back to our skills we've taught before on sectioning, right? So if you're new to this, let's turn on some section views. So you're going to come up to Viewpoint, and you're going to click Enable Sectioning. Okay? And somewhere on those machines you guys are using, you should be able to go to the section plane settings. And we're going to turn on the front one and the back one and turn off top. And you know what? This is oriented weird, so we're gonna have to. I just realized that I should. This is gonna make for some interesting, because it's got a strange angle. So we're gonna have to manipulate these to be a little more square. But there is a way to do that. If you notice, you can rotate these and grab the little green and turn it. Just make these section planes line up to north-south of the building. Did you guys see how I did that? So now we're starting to get some real data we can analyze here. So has everybody got a cut somewhat like that? You can bring in the left and the right, but you're going to have to rotate them all because they have the true north rotation, which I forgot about.
So you just want us to get the data room 137?
Yeah, section it down to where you're not, sometimes, you know, you start seeing too much data.
Data room 137. So all the other rooms you don't want us to show, just data room 137? Is that correct? Sorry, I was just
yeah, just section it down here. I'm going to turn this back off. Sorry.
How'd you align the plane to the north face or south face?
Okay.
Yeah, they're all struggling with this.
So let's just turn on one at a time here. I'm just going to turn on the front section plane, right? So when it comes in, it's rotated like that, right? Something like that. So in the section plane settings, select that section plane, number 3. It has to be blue like this. So like, for instance, I just turned on the back. I don't want the back. I want the front selected. It's at an angle. Up here at sectioning tools, instead of moving it to where you can push it in and out, you want to rotate it. So change it to the rotate manipulator and grab this green half circle or quarter circle on the bottom, pie shape, and just rotate it to where it kind of matches up to the CAD plan. And you do that for both front and back. And now, that's interesting. How did I get back rotated so messed up? I'm going to get that one fixed. So put my back here. And then you want to switch back to the rotate or the move, right? When you're done. You don't want to rotate anymore, so switch back to move. And you should be able to bring it down to where you can look just like at a single set of conduits here. Right, you can pull this in and look at just one wall of conduits, and it makes it a lot easier to see when it's like that, right? You can see those red lines. You can tell right where you're at. All right, I'm gonna do you one better though. Gets better than this. Okay, so the CAD background's nice. Let's turn our 3D back on, our 3D CAD wall or our 3D Revit model. Unhide that guy. And let's just make the whole thing somewhat transparent, like a 30% transparency. Okay, so did you guys get it to where you've got both the CAD, the scan, and the AutoCAD or Revit 3D in there? So tell me, what would be even better to see than just the architectural model, the scan, and the CAD? What would help us even more? This is fully BIMmed, this project. Every bit of underground, everything. So what should these guys be building this to? What should they be trying to hit all of these points out here in the field if we did a full underground BIM? That should match their BIM model, right? So Mo is pretty sophisticated. Their BIM, they produce points out for their total station, and that guy, he's the only one who didn't have screw-ups out there or major, because he was using the control that was still good to sync up his total station. Everybody else, Couts and the electrician that measured off the grid lines that were bad, they ended up in the wrong place. For instance, if you look at Coutts big pipes that are stubbed up, that's an interesting looking one. Move this section north, you'll notice right above the data room there's this big chase, right? And notice you got a bunch of pipes in here. In fact, you could probably even turn your, I've never tried overriding the color of the laser scan. Let's try it. Let's make it all red. There you go. Nice. So now, what do you see as a problem with where they're coming up in the chase? I see a big problem. Their insulation and their pipes is partway through that stud wall, and that's where they had it ready to go. They were going to slurry that thing in soon, so we were already telling them they had to push it in. So I think the laser scan probably views best. It can work one solid color, but I tend to leave the appearance because it still records gray scales, so it's not just all gray. You can see, you know, there's quite a bit of color to it. I mean, I did one scan in color, the rest were black and white.
What was the issue with those pipes in the wall?
Right here. So if you expand it to the north,
Yeah.
I mean, you tell me. Here, I'm going to bring up the bottom clip on this. I'm going to just cut out. You tell me what's wrong right there.
Yeah. Got it.
They're not in that chase. That's the spot they got to hit. Notice the plumber, though. Notice where the plumber's at.
Yeah, plumber's right in.
Because he's using a total station on good control.
Yeah.
So almost all his points were on. So now I have an even better Navisworks NWC for you to use. Okay, so I want you to go back if everybody's with me. Okay, so hide this architectural NWC. We can leave it in there. Navisworks can handle hundreds of these things. I got another one for you to bring in. Home append. So normally this would be put into our full detailed clash model, right? So now click this one, B360 MEP Underground. Okay, and when you expand that, you'll notice you've got multiple,
Disciplines.
trade models underneath it. So, for instance, let's take the electrical and we'll make that guy green because that's our usual electrical green. Mo, we're going to make magenta, all Mo's stuff.
Is that on here or on here?
What is what?
B360 underground file.
Yeah, it should be, it's in there.
In here.
It's not in your data set?
No.
Yeah, it should be in there. Maybe you copied that one before I made that file.
Most likely.
Okay. So now, not only can we tell them, hey, you guys missed, or we could even tell Mo, but check this out. I mean, look at Mo's layout. Like, they aren't slurried in or anything. They're just laying on 2x4s. But you can really start to QC all of this and say, hey, your BIM shows these in quite a bit different spot, or your spacing quite a bit different. Maybe they, for good reason, have them there, but I know Mo is in the chase, but you can see how much, you know, the positioning is off.
How do I undo the laser scan being red?
Oh, good question. So when you've made color changes to something, come back, click the whole file. So click the whole RCS file right here. Item tools, reset appearance. It resets it to the original grayscale or whatever it was. Right, so these guys have all produced shop drawings. This is an Oshpod job. These BIM models have everything, every seismic in it. We're pushing them to a very, very high level of detail on this one. And so their shop drawings are all coming from the BIM, fully dimensioned. So these guys should be attempting to hit these locations. So you can see like how quickly, a few hours out in the field, you know, it's possible to turn this around in a day's time, right? We come out there, we shoot it, we register it, we put it together the next day, give it back to you guys, all overlaid, ready to go.
It looks like their BIM model is more accurate.
Well, yeah, it should be, right? It should, the BIM model is the desired outcome, and then you're seeing the laser scan is what the layout is, right? And you're trying to QC this. So you're looking at things like this over here. You know, he has 3 conduits to put in here. He's only got 1. I mean, you could check quantities. Did they miss any, right? And I asked that earlier, and Eric and the team were like, yes, he actually has to put 2 more in, but because you can see Coutts pipe underneath, they had to dig those in, and they have to wait to put these in after.
Right.
But I mean, take a look. Like you can travel down in here and see spacing in the trench. The inspector was actually questioning them on their spacing because this detail has a very specific spacing, and you notice all their pipes are closer together than that. So I mean, we can come out here, we can check these vaults. So this was another point of interest. Were these vaults over here. So I'm gonna sectioning, move this guy. I'm gonna turn off my NWC for a minute here so I can see what I'm looking at. Bring these guys in. Right, big thing, vaults, if they don't get set at the right height and the stuff in them doesn't move, I mean, you can check that. So this is what it should have been. Right, so you can see their layout is a little different in the field. Might not be a big issue, although it's very tight in here with a lot of trades going around it. And their height is, yeah, so I asked them that. We asked them that when we shot it. Remember what he say? I said, you can't just immediately tell them they're wrong. I asked, what, you got a lid or do you got a riser ring on this? And what did they say it was? Yeah, so it's the lid part and the riser ring that goes with it was like a foot and an inch or something like that. So how could I measure that? How could I tell if he's going to be right or if we're going to have grade issues when he puts that on, right? We can use our measuring tools because you can actually measure. So we would want to lock Z just to make our vertical. You can measure to every single dot in the laser scan, by the way. So there to the top of that guy, 1 foot 1 and 7/8 are going to be right on the money on the high side. So elevation wise, they're good.
Everything is off 4 inches left or right.
They are.
Because of the,
yep.
The west.
Yep. So we obviously don't have to move everything, but the stuff that's critical in walls, that's on the surveyor. These guys are having to fix it, and it's going to be a bill to the surveyor.
That's an expensive bill.
Yeah, and we caught it early.
Who's
I mean,
the surveyor on this?
F3. They're on this one, an ACE.
Okay.
So good thing to know that the BIM department can check your survey control, you know, etc. But then, I mean, this visual. So Eric, I'm sure, maybe he'll chime in. So Eric, this was the next step that I didn't have time to do for you on Thursday. That's why I just gave you the PDF. But now you can have this complete model to be able to show them all of it overlaid. Does this seem helpful to you?
Oh, definitely. It gives the perspective of the, you know, how many inches and I could dimension from there straight from the model. So it's definitely helpful. It really does help in the field, you know, double checking and making sure that they're on point, and if there's any hiccups, you know, we could catch them early and move on instead of, oh, they're good and then come back, break some concrete. So it does save some time, and it's good for the project overall.
Awesome. Tell us, like, so where is it at out there? Are they still working on fixing this stuff?
Yeah, they've fixed most of them. They're, I believe, some backfilling and compacting right now as we speak. So they're making some progression.
Yeah. So this one concerns me. Did Mel Smith realize that they put, like, this conduit is going to be, well, the small one next to it, hopefully it's above the footing, but that big one, that thing's almost, I guess it was supposed to be almost rubbing the footing. But I'm worried about these two little ones above it. Hopefully those are above the footing underground, not because the footing's not there yet. So that would be a good thing to review on this whole thing, Eric, is if you turn all of this off, you could expand this MEP underground, go to the structural concrete model, and just make that guy like a dark green color so we could see those footings and really start, you know, making sure that the locations above those things, because see there, these two conduits right here are above that footing. So hopefully they're height-wise rolled above it. Otherwise, if they're coming straight up through from down below, that means they're coming straight up through the footing and they're going to have to move it.
I think they're a little higher. I need to double check though. Hey Jared, I don't have the scan file though. Would I be able to get that?
Yeah, that's what I was saying. It's a big file, so I got to run it out to you because it's, you know, this one is the smaller version of it and it's still 6 gigs. So I'll run it out to you, or yeah, I could probably just run it out to you on an external.
If you're at the main office today by 5-ish, I could stop by.
Okay, sweet.
All right.
So that in context, so we did this on this job. We've done this to check embeds of this CMU. We have another. In fact, I could probably just bring it in right now because it's on my D drive. You won't have this in your data set. Recap, part view, make ready, CMU. And this is the full RCP. But if I bring that in, you notice that one too. I'm going to hide the other one. So now here's the CMU from the make ready, and you can see like embeds and everything. We can check. I mean, you can even on that one, you can almost even read their chalk pen on there. As far as the embed number and all that, but we checked all the embeds on this to see if we were going to have any issues too tight, you know, where the beams weren't going to drop in. So that was one we did. Let me pull that one out of there. Delete. Give you another one here. We did foundations. So we could check same thing on the make ready, stubbing up. So that one's full color. So like,
sweet, you came out on a 4-day, huh?
Yeah. Oh yeah, check this out. You'll love this. Look at that thing.
Spider. Yeah, that's freaking sick.
That's just the different boom position that every different scan caught, but it looks like some big alien monster. It's a transformer.
That one needs to be saved. Yeah.
So you can see though here, like, you know, looking at these, they're actually, I mean, and that's the thing, they were right up against the formwork of the foundation that was being poured there, but we were checking.
So is this a standard practice moving forward in all our projects? You guys are going to come out during utility phase just to see how close they are? It
is, and we can if we, so that's why, like, you guys knowing what's capable, obviously it's still a time thing, right?
Oh, yeah.
It's a time investment, but we've gotten to where we can round trip it fast. And of course, the less we have to scan, the better. So if we do it in small chunks or whatever, but realistically, we'd be out there for 3 to do all those scans, and usually 2 of us would come and survey them 3 to 4 hours. Come back, it's about 4 to process that many 12 to 14 scans, and then bring it in and then get it set up in the model. But I mean, as you can see, the amount of time, and that's what I just talked to Ryan today about surveying the embed plates on them.
We're asking you guys to come out on Tuesday. Or
now he's saying probably Wednesday morning it'll be clear because he talked to the mason. But yeah, I mean, you can see the value. Like what I was looking at this one closely in like cutting in sections, and you can even see the trench of the foundation, like the rebar cage does a little belly and comes back up. And you could totally see that when you cut a section in here, because you can see the solid Revit models footing, and then you can see the rebar cage that was in there from the scan. So yeah, we have all these different, and that's why having that good coordinates, good control established at the beginning of the project, and we're pretty good out there at Etiwanda. Etiwanda's a little challenging in the fact that the control that's just outside the fences is now getting hard to see if you want to sink inside the building. So that's why we have to ask Ryan, like, next time your surveyor comes, make him give you control and the coordinate data that goes with it inside, so we can set up somewhere in there and sync up in the building and start to shoot stuff. So obviously outside's a little easier where you have more straight line of sight, but clearly it can be done. So I think being able to give you guys this data and you know how to use it, I mean, it's pretty simple once we have the coordinate systems lined up, but some of those little nuances to it about making sure the units are coming in right, that it's detecting the units of the different, and because I never actually did this part, but if you right click on the RCS, notice it detected it accurately. It's in meters, but everything's still to scale because that's what it truly measured it in. So Navis did its job and detected that one correctly.
You think we could do a training class on actually doing the survey with you guys?
Yep. So these guys were encouraging me. Eric and the team were saying, hey, you know, we could really use you out here like Monday. And I said, I got a BIM training. They're like, why don't you just do it out here and use the total station?
Yeah.
And I just wasn't prepared to have a whole class, and not to mention the turnout was not so good on this one anyway, so it'd be better when everybody could come. But
because then we can just, I don't know if you guys will allow us to borrow that, but maybe we can use it with one of you guys so we don't break it.
Absolutely we can. Our goal is to get some people trained, and quite honest, most of our a few of our supers, I should say, are the ones kind of very interested in being able to use it to check things early, because that's the hardest part. Once there's enough of the building there, it's not so hard to go out there with a tape and go, dude, you blew it. Yeah. You're off, right? I can measure from this wall to that one, and I have a dimension on the floor plan. But when it's wide open dirt, that's the part. It's going to be most beneficial. Once you guys have enough CMU walls, you're working within the constraints now.
Right.
You won't need so much of it, but it's truly majorly valuable here.